Hi guys, welcome to Honest Sciences and Mathematics TV channel. Today we are going to do a continuation of the previous videos that we had discussed on the radioactive decay processes and the various characteristics we had mentioned for the general three processes of alpha, beta, and gamma radiations respectively. So for today we're going to look at one of the characteristics which is of course the concept of alpha decay. And these decay processes are going to be experienced basically for elements that are heavier than lead and for a few nuclei, which of course are going to be as light as the lanthanide elements in the inner transition elements that we had mentioned on our discussion in the periodic table. So therefore, we are going to see that this is going to be described as an helium nuclear, which is going to be given such for the alpha decay. And if we try to look at how this one can basically be described, we had said that the nucleus changes which are going to be expressed in this alpha decay, which we have given a symbol as that, is going to cause an effect of the mass number and of course the mass number and the atomic number, which are going to be given as a difference for for 4 and 2 respectively. And therefore we are going to have a general equation that is going to represent this specific case for the alpha decay being given as a general representation for an element, as we had said. This X is going to represent an element, and therefore we are going to have for the atomic mass and the atomic number being given for A and Z, and the products for this alpha decay process is going to be given for that specific symbol. This one can be another element, of course, which is going to be as a result of the radioactive processor, which is going to change the mass number and the atomic number for that specific difference that I've mentioned. So therefore, we're going to have A minus 4 and Z minus 2 for the atomic mass, of course, for the mass number and the atomic, for the mass and the atomic numbers in that specific respect. And therefore, this is going to lead to the production of this specific product for the alpha particle. As we had said, it's a helium nucleus, which is going to be given as such. So in this specific case, we're going to see that this particular illustration is going to follow a normal case for the equation that we give, especially in the chemical reactions, which are going to follow the aspect of a conservation of mass, the loss of conservation of mass, as other equations that we see. And of course, we had said that for the loss of conservation mass, we had said that it's just be able to experience a transformation, but we're not going to see it changing in another way. So therefore, this one can be assumed to be some kind of a stoichiometric form, whereby we are going to see that the mass number and the atomic number are going to be, of course, equivalent if we try to consider the products and the reacting, the product side and the reactant side, respectively. So therefore, as I've said, for the general illustration of an alpha particle, it's going to have a total effect of the nucleus changing to that of a different element according to this specific equation. And of course, as we had said, they are higher ionizing and weak penetrating, and therefore they're going to be stored by a sheet of paper. Now, in trying to look at a specific example for this kind of radiation, we can use an example for uranium 238 and 92 are given as such. So therefore, if it's experiencing an alpha decay process, it's going to produce thorium. Now the difference between this one and this one for the product, for the mass number and the atomic number, is going to be 4. So this is going to be 234, and then this is going to be 90 for the atomic number respectively. So this is going to be accompanied by the release of an alpha particle, which is going to be given as such. So this is the alpha decay process for uranium 238, which is going to be illustrated as such. So as we said, that this is going to be accompanied by a release of energy. As we had mentioned in one of our videos, that there's a concept of a binding energy, which is going to assist create an equilibrium for the nuclear forces for the short range and the strong, of course, repulsive forces, which are going to be experienced in the nucleus due to the presence of protons and the concept of stability. So in this particular case, this is a specific aspect that we can give for this particular kind of radiation, which is an alpha particle. So of course, we will be giving various examples if you try to create an emphasis on this, which are going to understand us, assist us understand how we can be able to, of course, describe other various elements which are going to undergo this specific process of alpha decay. So that is it for now, guys. Catch us in our next video as we're going to look at another product for the radioactive processes and other discussions which are similar to this. So checking out the description boxes, and kindly subscribe to our channel so that we can be able to assist one another in these various discussions that we are having. So that is it for now. Bye guys. God bless you.